Troubleshooting OSPF version 3. For consistency, I'm going to use the same topology that I've been using for the other IPv6 routing protocols. Let's roll OSPF version 3 on top of it, and let's make it a little interesting. I'm going to make this right here area 0. And down here, we'll make that area 1. Right, just so we can get a little multi-area action going on. So let's start off on router 1 up there. First thing that we need to do is go into global config mode. Of course, make sure our IPv6 unicast routing is turned on and all that. But past that, we do IPv6 router OSPF. And we'll do process ID 1. Now again, process ID doesn't really matter what that number is. Notice it comes up with an immediate error. It says OSPFv3 process 1 could not pick a router ID. Please configure manually. That's because this router does not have anything to do with IPv4 routing, and OSPF uses an IPv4 address as its router ID by default. It tries to dynamically pick one using a whole set of rules, right? So since we don't have one, I have to come in here and do router ID 1.1.1.1 or whatever ID I want to give it. It's not necessarily important which one I give it. Then I'm going to bail out of this router configuration mode and get up to interface fast Ethernet 0/0. Let's configure that one first. We'll do IPv6 OSPF1 area 0, right? We've now defined this interface right here, fast Ethernet 0/0, as connecting to area 0. And with that, we're ready to go down to area 2, or to router 2. So I'm going to go over to router 2, same kind of thing. Doesn't it get so much easier in IPv6 than it was in IPv4? No network command makes it just that much easier. So IPv6, router OSPF1. I'm way ahead of myself. I'm on IPv7 already. We'll do router ID 2222. Exit out of there. Interface fast Ethernet 0/0. We'll do IPv6 OSPF1 area 0. And we'll exit out of here and do interface serial 0/0. IPv6 OSPF1 area 1. Good. Now at this point, we should start seeing some communication happen between router 2 and router 1. So let's do a quick show IPv6 OSPF neighbors. And I can see that it is currently in a two-way druther state. Let's take a look. Show IPv6 OSPF neighbor. Currently going through the XStart. It's saying the other guy is the designated router. Let's give that a little second while we are configuring that last router, router 3. We'll go into global config mode, do IPv6 router OSPF1. IPv6 router OSPF. What did I type wrong? Oh, OSPF. There we go. And do router ID 3333. And then finally go under interface 0/0/0. IPv6 OSPF1 area 1. And that should bring that neighbor relationship up. There it is. We can see it's now moved from loading to full. Show IPv6 OSPF neighbor. And we can see we're in a full state. Let's go out and check router 1. He's settled in now, right? They had their little DR debacle and had a election. You can see that we've got, let me just scoot this over a little bit. We now have 2222 showing up as the neighbor ID. Full, he is the DR, which means router 1 is the BDR. Just hit the up arrow there and we should see the BDR. On the point-to-point link, it is showing that there is no DR or BDR election because they are both seen as that full neighbor relationship. You don't need anybody to balance the number of connections that each neighbor has because it's only 2. Okay, so let's go back to router 1, do a show IPv6 route. And sure enough, we see OSPF is learning about these routes. It is an inter-area route, which is represented in IPv6 as OI. And then over here, I've got 2001 DB8 6783 121. That's representing this subnet down here, the one that he did not know about. And I should be able to go over to router 3, do a show IPv6 route as well, and see another OI. OSPF inter-area route of 123 happening right there. The things that can go wrong with OSPFv3 is almost identical to what can go wrong with OSPFv2. Interface is down, ACL is blocking, we've got mismatch area numbers or area types or timers. Remember, OSPF is super sensitive about forming neighbor relationships. You got to have the right area, you got to have the right subnet mask on the interface, you got to have the right timer set, the right area type, and area type being stub, totally stub, not so stub, all those kind of things have to match or else it will tear down the neighbor relationship. Having duplicate router IDs could be a challenge, and this is probably more of a challenge in v3 because if you are going true native IPv6 everywhere, then you have to manually set those router IDs, which means there's more of a chance of saying, oh, well, if you don't have a scheme behind it, right? Just thinking of 1.1.1.1 and accidentally using that in a couple places. Now, the problem with that is it's one of those things that you're going to have a neighbor relationship somewhere in the area fail, and it's going to be a pain to figure out why. So it behooves you to really document where your router IDs are, or at least come up with a scheme to ensure you don't accidentally duplicate any of those. Passive interface, obviously, remembering where those are, because if you have an interface marked as passive, the neighbor relationship will not form at all. Authentication mismatch, as always, or the wrong designated router is elected in a hub and spoke environment. You remember with OSPF, the whole goal of the designated router. Why is my pen is cutting out on me here? Oh, it's because I'm drawing on the wrong layer. There we go. The whole goal of the designated router is to make sure that it is not I'm like, what is the goal of the goal of designated router is making sure that we don't have this flurry of advertisements, right? Like if you've got a router connected to a switch with let's just say 4 other routers attached to it, right? You don't want anytime there's a network update this guy to tell everybody, and then everybody's like, oh, it's like a fireworks explosion, you know, letting everybody know about this update. So what they said is, okay, choose a designated router that will be able to step into there, and everybody notifies the DR one time, and then the DR can notify everybody else. Well, in a hub and spoke topology, if you, for instance, let's just say this is the hub, spoke, right? And this guy doesn't exist. If that's the case, and you elect this guy as the designated router, well, what's going to happen is this guy will not form full relationships with these guys, because he's going to be like, hey, I got the DR, me and him are tight, you guys are going to be two-way relationships, and that means that you're going to have a break in your continuity of your networks, because these will not form neighbor relationships nor advertise routes with this hub, and it will not communicate over here to router 2 at all. So always make sure that the hub of your network is elected as well as the designated router. Well, let's wrap up by taking a look at these show commands, just so we're all comfortable with what they can display for us to see. Alright, I'm sitting on, let's go over to router 1. We'll do a show run section OSPF. And that will show us the snippet, if you will, from the running configuration where OSPF is valid. This one obviously came from the interface. Right here is the router configuration mode and all the commands that are typed underneath it. We already saw show IPv6 OSPF neighbors, but I put it second in the list because that is the second most handy troubleshooting command that you can have. If you're not seeing routes, verify that the neighbor relationships are there. Show IPv6 route, OSPF zooms in on just the OSPF routes it's learned. Show IPv6 OSPF will show you kind of the protocol details for OSPFv3. You can see your router ID, you can see the timers that it's using when it's communicating. You can see the number of interfaces that it has in each one of the areas. Router 1 is only a backbone router, whereas router 2, I believe, is our ABR. Let me just verify that. Yep, you can see that we've got area 2, one interface in the backbone, one interface in area 1. We can do a show IPv6 protocol, again, flyby view of which interfaces are actually running OSPF. Show IPv6 OSPF interface is huge for checking your timers, because if these are off, the neighbor relationships will not form. You can see right there is our hello and dead timers that we're using both for fast Ethernet 0/0 and then right below serial 0/0. Finally, you see the last view, the debug hello and debug adjacency. Those debug commands allow you to see obviously the hello messages, but more important, the adjacency happenings as the neighbor relationships are forming. If you do a show IPv6 OSPF neighbor and you're seeing your neighbor relationship is not there or in the state that you expect, then do this debug IPv6 OSPF adjacency and you'll be able to watch the neighbor forming and where it actually stops and breaks down. There is how you troubleshoot OSPF v3. I hope this has been informative for you, and I'd like to thank you for viewing.